Welcome Year 12s to this next video. As promised, I will upload a couple of videos that will take you through the first part of our the next section of this topic of statistics, and that is that we're going to start looking at associations between two variables. So no longer are we just going to focus on one variable at a time, whether it be categorical or numerical. We're actually going to look at two variables at once, and they could be both categorical, both numerical, or a mixture of the two. And from there, we're going to see if there's an association between the two. So that's our main concern always when we're, say, making a frequency table or a segmented bar chart or whatever it might be, a back-to-back stem plot. We're always looking for whether there is a relationship between the two variables that we're investigating. Now, one of the first things that we need to do when we do this is establish that there's a difference between our two variables that we are looking at. So we call these response and explanatory variables. We used to call these independent and dependent variables. So if you've done the General Maths Unit 1 and 2, you'd be familiar with these terms. Or if you've done psychology, you'd be familiar with these terms, probably the response and explanatory variables. Those particular terms you have come across before. So what I wanted to do to begin with is just let you know that quite often we will not write out response and explanatory in full. We'll just use as an abbreviation RV for response variable and EV for explanatory variable. And of course, in the past, that used to be IV and DV. So you are going to have to get used to the change. I'm sorry. So what we're going to do is, first of all, start thinking about, well, why is there a difference between two variables? Why do we need to consider the two being as, one explanatory, one response? The reason is whenever we're looking at this relationship between two variables, we're expecting that there'll be one variable that might explain the values or explain any changes in values to the other variable. Now, this doesn't mean that we're looking at one causing a change in the other, because we don't really look at our data in that respect. Try to avoid using those terms always, because we know there's loads of other factors that are involved when you're looking at two particular variables. There can be other reasons why your variables are changing the way they are. So what we'll do is we'll use the word, I'll try and use the word as much as possible, explain. Does something or can something explain particular changes? So it may not be 100% explaining the change, but if there's some sort of relationship, what we want to do is work out, well, which variable is explaining the values in the other variable, or can we use to attempt to explain the values in the other variable. And from there, what we can do is try and predict this second variable. So we can predict the values of our response variable from there. So what we'll do is first look at this one here. If we were investigating if older people sleep less, here our variables obviously would be the age of the person and how long they spend sleeping. So from here, which one do we think explains or can attempt to explain the other? Does your age explain how much you sleep, or does how much you sleep explain what your age is? So for this first one, generally when you've got age, when age is involved, a lot of the time your age will be your explanatory variable. So what we're saying is your age here potentially has an effect on the time that you spend sleeping. We don't say that it does, that it causes you to sleep less, but we think that there might be a relationship between the two. And from there, what we do is we think, well, then maybe we could use age. We might be able to use this one to predict the time spent sleeping. We wouldn't take your time spent sleeping and predict your age from that. You can see that that doesn't quite make sense, does it? If we took time spent sleeping and said, oh, okay, you don't sleep much, that means you're 80 years old. That doesn't quite work, especially in all statistics, in fact. We never say that one thing is obviously going to lead to another. We're just looking at if there is some sort of connection. So that's our first one. What about this one? The relationship between kilojoule consumption and weight loss. So here we've got two variables, here they're in italics. So which one is response and which is explanatory? Well, here what I would expect is that the kilojoule consumption may explain weight loss. And from here, we could use the EV to make a prediction on weight loss. We could have a look at kilojoule consumption of a group of people, say that we're on, I don't know, on a diet or something, and we could predict from there using, well, you'd need a lot of data obviously, but you could make a prediction from there on potential weight loss. You can see that there are various other variables at play here. So obviously with that one you would want to know, well, how much are they exercising as well. So that's an example where there are other factors at play. What I wanted you to do was to read through this and to have a go. So I'm hoping that you have done that. And from here we want to identify the EV and RV. So here, if I wanted to investigate, we've got age and its diameter. We're going to say, hopefully, the age of the tree would explain its diameter, because obviously it's getting larger as it grows older, and from its age we could predict its diameter. Study between the weight loss, I've accidentally put that in, I would normally not put two weight loss examples in there, but weight loss and number of weeks a person is on a diet, okay, well, we'd expect that the time that they've been on that diet would explain their weight loss. Data collected, we've got here age of a second-hand book and its selling price. So again, you can see how age comes up a fair bit. We'd expect that the age of the book would have some sort of, will explain perhaps the price of it. Number of hours a heating system's used and the amount that's used. Well, obviously, time that you've used it should explain the amount that you've used in most cases. And finally, relationship between number of runs a cricketer scores and the number of balls bowled to them. So I would say that the number of balls bowled will go some way in explaining the number of runs. Okay, from here, ladies, I want you to have a go yourselves. It's exercise 3A. I'll try all of them because there aren't too many and they shouldn't take you too long either. So I'll stop this video here and I'll put the next section in a separate one.